Hi students, in last video we covered FBDs, right? How to draw FBD diagram, and we did one numerical also. Okay. Now in this video we observe what are the types of FBDs. Okay. In that the first type is Atwood machine, and the second type is horizontal table, and the third type is Moses on inclined plane, and the fourth type is Moses with angles. So today we will cover one by one in this video. Let us move to the first one. What is our first one? Atwood machine. So in Atwood machine, come on, let us observe what is Atwood machine, what it contains. So mainly it contains, you observe here there is a pulley, right? Here there is a pulley, and then two mosses are attached. Okay. Here I am taking the condition that, let us take the condition for this two mosses M1 is greater than M2. I am taking like that, and I am attaching these two mosses to the pulley. Okay. Now what I said, whenever you want to calculate any kind of like tension or acceleration due to gravity, these quantities we require FBDs. By using FBDs for the total system, we can easily calculate the unknown quantities like G, okay, and then tension and acceleration. Okay, so for that, let us draw. In order to draw the total FBD of the total system, we are splitting that into two blocks. How many blocks are there? Those many blocks we are dividing. Okay, let us divide now the total system into two parts. What are those? First, our first block is, this is M1, and the second block is M2. Okay, so that we will draw FBD of M1 and FBD of M2, correct? To get the total system FBD. Yeah, let us draw FBD of M1, FBD of M1. Okay. So in order to draw the FBD of M1, come on, let us observe this. Here you can observe that here the body is moving. So because M1 is greater than M2, let the body moves like this. So sometimes they will give the figure like this to confuse you. Like M1 is, even though M1 is greater than M2, M1 is moving, because M1 is moving upwards and M2 is moving down. They can give like this. But actually, what is our figure? M1 should be down and M2 should be up. So in order to say that, I drawn this figure. Okay. Sometimes they will give the numericals like this. Okay. So let it is moving, because this is actually in our case this is M2, right? This is M1, right? This is M1. So now let say it is moving upwards. Okay, now let us draw the FBD of M1. FBD of M1. FBD of M1 is M1 we are taking. Okay, now for this black, you see here, there will be a thread or rope, something through the pulley. We have two blacks, right? So if something, a thread or something means here, you can definitely get a tension. Yes, you can definitely get a tension, right? Yes. Now you observe here, what I am doing is, this tension, how it is moving? It is moving like this. Yes, upwards. Say tension is always away from point of contact, right? Now, so in the same way, how the figure is, in the same way, I am drawing the free body diagram. So the tension is also acting. The tension is acting in the upward direction like this. Yes, very good. And then now what about if the tension is acting like this? No doubt we know there is downward force. What is that? What is our downward force? Mainly the downward force, that is, yes, correct, that is m1 into g, right? Gravity, because acceleration due to gravity, because any mass existing means no doubt there should be acceleration due to gravity exists, right? So down you have m1g. Yes, because this is mg and this is m1g. So how the acceleration is acting here? Like this. Okay, this is our FBD of m1, right? Now let us take FBD of m1. Yes, FBD of m2. FBD of m2. Okay, now you observe the second block. What is that? Our second block, that is which is having a mass m2, right? And now what about the tension acting? Tension is acting upwards, okay, and downwards there will be m2g, okay, and acceleration is upwards, right? We are moving like this, okay. Now you observe, if we write the equations, this is tension, no? Yeah, this is tension. Now if you write the equations for these two, first let me write the equation for FBD of m1. Come on. So here the tension is moving upwards and m1g, the tension force is upwards and m1g is downwards. So how the body is moving? The body is moving. You see the acceleration symbol that states that the body movement. Okay. Here we have drawn the arrow mark downward. That means the body is moving downwards. So whatever the things we are taking, those should be, all forces should be downwards, which are downwards can be taken as positive. This is very important point. I explained in the last video also. You check. Okay, here you observe that the body is moving downwards. So if the body moves downwards, then whatever the forces which are in the downward direction, those should be positive. Then opposite, the remaining all, that is upward forces, should be negative, like that we are taking. Yes, come on, let us take and we will write the equation. Now what about, whenever you take any kind of system, we have to take the total forces acting on the system. So the total forces acting on the system, according to Newton's second law of motion, F net is equal to m into a. No doubt we know this. Now, what are the different forces we are acting? That can be total forces we are finding, and this is also the total force. If you equate that, you are getting the equation. In this way, we have to go. Okay, let us move. Let us go to the equation now. Let me write the equation. Come on. You see, it is moving in the downward direction. So can we take that m1g as, because this force m1g as positive, right? Yes, very good. M1g is downward force. So our A arrow mark is downward. So you do one thing always. The motion of the body, moving means it is having some acceleration, okay? So the acceleration, you put the acceleration symbol and the body movement like that. So you take all the, wherever you observe the acceleration, those things should be positive and the remaining things should be negative. Like that you go. Opposite things, okay? Opposite things should be negative. So here, can I take M1G as positive because A is downwards and body is moving downwards. So M1G is positive. And what about T? Tension. Yeah, tension is opposite to the motion of the body. That's why, can I take negative as T? Negative T? Yes, very good. Negative T. And this is the total force we are getting according to our only for the block of M1. correct? So for each and every block, the total force exists, right? So what is our total force according to Newton's second law? It is ma. So can I equate this to ma? Yes, very good. Yes, yeah, but here, what is our mass? We have to take with respective mass, no? So can I take it as m1a? Got it? So this is our equation 1. Okay. Now, let us write the second equation. In second, come on, look at the FBD of M2. In this case, you observe here, because the body is moving upwards, right? You see the arrow mark, what I said, you see the arrow mark of acceleration. This always states that the body movement, you keep in mind. Okay, so the body is moving upwards. Okay, if the body moves upwards, what happens? If the body moves upwards, all upward forces are positive, so you start with positive, it becomes easy. So positive, which is our positive force? That is tension. Okay, T. And what about opposite direction force? That is M2Z. So can I take it as negative? Yeah. What about this is the total force. What is about our total force? Total force is F net. F net is equal to MA. But here with respect to M2, yes, M2A. This is our second equation. Yeah, you got 60% of the equation, 60% of the equations. If you got total equations, you got 60% of the total problem done. Okay, that is what is our problem? Our problem is to calculate G and T, A, G, T, or you can take A and T only. We are going to calculate. No need of G. Yes, so you got 1 and 2, right? Now, in order to solve these two, what we have to do? Just we have to either add or subtract, right? Let me write all the two equations. M1G minus T is equal to M1A, and T minus, so T minus, this is plus T, no? I'm writing under this. M2G is equal to M2A. Okay. Now what you do, if you add these two, then T is going to get cancelled. You are getting, what are you getting? M1 plus M2 times G is equal to, just I'm adding them. I'm getting again here plus, right? A into M1 plus M2. Okay. Now we calculate G first. Okay. What about G? M1 plus M2. M1 plus M2 times G is equal to, M1 plus M2 times G is equal to A into M1 plus M2. M1, sorry, here minus, no? M2 is minus. So M1 minus M2, sorry. M1 minus M2 times G. M1 minus M2 times G is equal to A into M1 plus M2. This is our equation. Now G is equal to A into M1 plus M2 by G we are calculating. M1 minus M2. Okay, I calculated G. No need of calculating this one. Okay, in this I am calculating. And now we are going to calculate acceleration. So from this we can easily get directly from this equation, from equation 3, we can easily calculate from 3. We can easily get A now. So what about A? Sorry, A is equal to M1 minus M2 times G by M1 plus M2. This is our A value, right? Now, I am going to put this A value in any one of the equations. So, first equation, can I put? Okay. So that we will get the value of T, right? Yes. Let us do that. Let us do that. Let me put that in that equation. Yes, next what we do? Yes, now we are going to calculate. Now tension we are calculating, right? T we are calculating. So A is equal to, what is our first equation? M1G minus T is equal to M1A. So in this equation, I am going to put A value. M1 times, what is A? M1 minus M2 into Z by M1 plus M2. I am substituting this, okay? Now, I am getting M1G minus M1G. What do we get? M1G minus T is equal to M1A. In this, I am keeping A value. So T I am calculating. So can I send this? Let me do one thing. So I will do M1G. I will take T directly. So T, positive T I am sending. So if you send this one, it becomes negative, right? So I am taking this as plus and this as minus in the next case. So T is equal to minus M1 into M1 minus M2, M1 minus M2 into G by M1 plus M2. Because what I said, if you send this one, it becomes negative. But I am multiplying totally with negative sign. So it becomes plus M1G. Plus M1G. So T is equal to minus M1 into M1 minus M2, M1 minus M2 into G by M1 plus M2 plus M1G. T is equal to minus M1 into M1 square. M1G, no? M1 square G. Okay? Plus M1 M2G. Or else you can send this one to that side. T you send that side. Okay? Can we do that? It becomes easy. Don't confuse with this. Let me do that. Okay? Yes, let us do that. So M1G minus M1 into M1 minus M2 times G by, this is M1 plus M2. M1 plus M2, which is equal to T. Is it okay now? Clear? So now you observe M1G is common in these two. M1G is common. Now what is left here? 1 minus M1G gone. So M1 minus M2. M1 minus M2 divided by M1 plus M2, which is equal to T. Okay? Let me erase this. Let us do now. What do we get? So what we are getting? M1G is common. Now I am taking LCM. So M1 plus M2 minus M1 plus M2 divided by M1 plus M2, which is equal to T. Yes? Okay. Now what are the things are going to cancel here? So plus M1 minus M1. So M2, M2, 2M2. Right? So 2M1, M2 can I write directly? 2M1, M2G, 2M1, M2G by M1 plus M2, which is equal to T. So we got the value of tension and as well as acceleration. We derived. So what is the condition for this? When M1 is greater than M2, we have taken this condition. If you do M1 is less than M2, you will get the same values also. Okay, you try that in the home and comment it. Okay, very good. Let us move to the next part. Next is, this is Atwood, no? This is Atwood, and next one is horizontal table, right? Now you observe the horizontal table. In the horizontal table, you have it just like a table you have. And one more note I forgot to say this. Let us observe this figure. Now in this figure, if you have sometimes in numericals, they are going to ask what is the tension at pulley. At this point, they may ask what about the total tension? What is the tension at the pulley? They may ask. So at that time, the tension, T tension acting on this M1 and T tension acting on this M2. So you take T dash, this one. What about the tension, total tension acting on this? If they ask, then the tension at M1 is because of M1 is T and because of M2 is T. Okay, both tensions. And then if they ask the tension at pulley, you have to simply add the two tensions. So 2T will be the total tension. Okay, 2T is equal to, T already we calculated now just now. Come on, look into that. What is that? 2m1 m2g divided by m1 plus m2. Okay, m1 plus m2. This is our what do you say? Total tension at pulley. Got it? M1 plus M2. 2m1 m2g by m1 plus m2. Tension at pulley. That is 2 into 2 becomes 2 into 2 becomes how much? 4 into m1 m2g by m1 plus m2. This is our total the tension at pulley. Got it? Yes, very good. Now we go to our next type of FBD, that is horizontal table. That is horizontal table. Come on, let us move to the horizontal table. You observe, this is just like a table form, whereas in the pulley form, okay? In the horizontal table also, the same conditions, whatever the conditions we are taking in pulley, same you have to follow. You have to get two equations. You consider M1 is greater than M2 or M2 is greater than M1. M2 is greater than M1. We take M2 greater than M1. Okay. So in previous case, I gave homework to you like M2, yeah, M2 greater than M1 in the first case. So now I am doing M2 is greater than M1 here, and you do this M1 is greater than M2 in the home. M2 is greater than M1. Okay. Yes. Now you take. So what I said, in order to observe the total system, we are dividing the total system into different. We are splitting the total system into two parts because here two blocks. So one first block M1 and the second block M2. So let us draw the FBD of M1. Yes, FBD of M1. Come on. If you draw the FBD of M1, this is M1. Okay. So here M2 is greater than M1, right? So M2 is going down and M1 is light. So how the body like this, no, it is moving. So M2 is coming down. Okay. So in this case, so you can observe the body is moving. The body is moving like this in this direction. Yes, M1 you observe because of weight, because M1 is more, M1 is less, M2 is more, M2 is going down, and M1 is on the top, right? Because it is light. Yes. Now you observe here, you observe here, what are the different forces acting? If you take any block, we know that a normal force and and what do you say, acceleration due to gravity, both are acting for each and everything. But if those two are balanced, then the body is said to be at rest. Okay, so the body is said to be at rest. Now, here you observe the body is moving. So there should be another force. Like that you can think. There should be another force. What is that our other force? Because by means of thread or by means of rope, you have another block, right? So because this thread or block, any spring, which generates what? Which creates some tension, right? Because of that thread. There is some tension is creating. So what is that? So how the tension is creating? You see, in the same way you can draw. You see, like this only I am drawing. Yeah, can I draw this as a tension? Yes, very good. Now, what I said, for any block, there should be normal force which acts perpendicular to the body, right? So this is our body or block, right? So there should be, we know that for any forward FBD, there should be normal force, yes. And also, what is the other force? Downward. What is the downward force called? Yes, very good. Due to acceleration, due to gravity, we are getting M1G. Very good. Yes, M1G. Yes. Now, we know the net force. F net is equal to MA. Okay. And then, now, here, here tension is acting in this direction, right? Okay. And here n is so how do we write now the equation? The tension is acting in this direction, right? If the tension is acting in this direction means acceleration. You see what I said? The arrow mark of A, I said. The arrow mark of A always states that the body movement, right? Acceleration is body movement. Okay. So here the body is moving in the same direction as that of tension. So you take tension T as positive, right? Is there any other force left side? There is no other force on the left side. So it should be 0. So that I am not taking that one. So can I take directly as M1A? Because total force T is equal to M1A, right? And you observe here N. Total N, no? Normal force. Normal force is equal to what can I write? Normal force is equal to here M1G, right? So because why? The body is moving only in the horizontal. What is the name of this? Horizontal horizontal table, right? Horizontal table we are taking. So the body movement can be observed only in the horizontal. That is from left to right or right to left. Okay, that is whatever matter. Okay, it moves in the horizontal motion only, right? Not from up and down, right? So that's why there is no movement in the vertical position of the body. So we can consider what is our when the body in the vertical position, if it is not moving, what do you say? The upward force is equal to downward force, right? So can I say N is equal to M1G? So that no vertical motion, that is vertical motion is rest, I can say. But there is no vertical motion. Vertical motion is absent. Yes. So that's why this top force, upward force is balanced with downward force, right? That's why N is equal to mg. This is very important concept. Because the body is moving in horizontal, what about the vertical? You think like that, and you sometimes they may ask, what about n? What is n? They may ask. They will give this kind of question. Generally, the student think that the body is moving like this in horizontal way. But what about the normal force? So normal force is same as that of the, that is M1G. Got it? Yes, very good. So we got first equation. Yes, very good. Let us move to the second equation. Let me write the FBD of M2. Come on, try that FBD of M2. You were born. First, you try that, and then you pause my video and you check it. Okay. Come on, now you observe. This is our M2 block, right? Yes, very good. M2 block, we are drawing the, what we are doing? Yes, very good, FBD. Yes, FBD in order to draw that. Now, how the body is moving here? The body is moving down, right? Why? Because it is a sumo, right? It is having more weight. It is going down, right? So yes, very good. So the body is moving downward. Okay. Now, what about this is the thread, right? So thread means it is acting, the body is moving downward. So thread is also the tension. The tension is also acting downwards. Can I write? Sorry, tension is acting upwards. Tension is acting upwards, right? So tension is always what is the main thing I said? Tension is away from point of contact. Away from point of contact. Okay. Now this is point of contact, right? This is point of contact. How the tension moves? Contact means the thread is attached to the block, right? So that is point of contact. These two are contacted at this point, right? So this point of contact, the tension is always acting away. Away means so it moves away, upwards, right? So opposite to that. So it is moving away from the point of contact. So this will be the direction of T. Very good. Now, what about this one? I am M2Z. M2Z is no doubt always it is yes downward direction, right? Now, correct. Let us write the now equations. Come on. How do you write the equations now? Here the body is moving downwards. So here M2Z becomes positive. Can I take M2Z as positive, right? You start with positive always so that you may not confuse M2Z. And what about the other tension? Tension T is upwards minus T, which is equal to, what is F net? F net is equal to here. F net is equal to M2A, right? So M2A. Yes. So you take this as equation 2, correct? So we got two equations. Now, what I do is, so we want to, what is our aim? We are calculating our tension and acceleration. Okay. So what we do? We substitute equation 2 in equation 1. Equation 1 in equation 1 can be substituted in equation 2. Okay. Substitute equation 1 in equation 2. Come on, substitute now. What do we get? Let us write the equation 2 first. So what is our equation 1? Equation 1 is tension T, no? T is equal to M1A. So tension is always only in the same way. Okay. Now M2G minus what is T? M1A. Okay. M1A which is equal to M2A. Okay. We are calculating G, correct? Sorry, A. Okay. Can we calculate A? M2G is equal to M2A plus M1A. Okay. Now let us calculate. So can we take A as common here? M2 plus M1. Okay. Which is equal to M2G. Now, what about G? G is equal to A times M1 plus M2 upon M2. This is our value of G in the horizontal table when M2 is greater than M1. Okay. So we got the value of G and A also I am writing. Actually, we want A and T. Okay. Now A is equal to M2G divided by M1 plus M2G divided by M1 plus M2. So this is our main A acceleration of the body. With which acceleration it is moving when the system is like this. This is the in this condition. Okay, that is M2 is greater than M1. Got it? Now let us move to the. Now we have to calculate T also, no? We have to calculate T because we got the value of A. Can we substitute this? Yes. Come on, let us substitute here itself. That value of A. Yes. Come on. T, we are calculating T. Yeah. Now A is equal to what? M1 times. So A is simply, so what you have to do? Substitute, you write one more step, substitute equation, you take this as equation 3. Okay. Substitute equation 3 in equation 1. Okay. Come on. Let us substitute that. M2G divided by M1 plus M2. What do we get? M1 M2G divided by M1 plus M2. This is our tension. In the horizontal table, when M1, M2 is greater than M1. This is our acceleration. M2G is M2A is equal to M2G by M1 plus M2. Okay. So here only the difference is that if you multiply with M1, A with M1, you are getting T, right? This is our equation, right? So if you remember only one thing, you can easily calculate the T value. Got it? So you got A and T. So this is about horizontal table, right? Now let us observe the very important model which is mainly for JEE main. Okay, what is that? That is inclined plane. We already know what is an inclined plane, right? What is an inclined plane? An inclined plane is a plane which is not just like horizontal. It is making a plane which makes some angle with the horizontal. Okay, that can be called as inclined plane. So because it is making an inclined, it is making certain angle, this can be called as angle of inclination. What is this called? Angle of inclination. Got it? So because it is making an angle with some angle, these two M1 M2 are attached with a pulley, right? So inclination with pulleys now. So here I am considering M1 is greater than M2. You observe whether the figure is given correct or wrong. M1 is greater than M2. So M1 is greater. Yeah, no doubt. It is because it is heavy, it is sumo, it is going down. Yes. So M2 is slowly it is coming, right? Very good. Correct. So now a pulley is attached by means of two M1 and M2. Then there is a thread. There should be tension, right? Correct. So now how the body is moving here? The body, so the tension, otherwise we will draw directly the FBDs, okay? FBD of M1. Yes, FBD of M1. Let us take the M1 block. This is our M1 block, right? So here they gave capital, so that I am taking small only. Generally we take small letters only, mass. That's why I took M1 small letter. Don't confuse there. Okay. Yes, correct. Now, what are the different forces? So one more thing I want to say, only the external forces can be considered. There are more internal forces inside the mass. Any block you take, because of any block of mass, okay, it contains atoms and molecular forces. All those forces cannot be considered here. Internal forces are neglected. Neglected. That is important. Okay. Only the external forces we are considering. Right. So here, how the body is moving. The body is moving like this downwards, right? You see, because M1 is more, so the body is moving downwards. Yes, if the body moving downwards, now what about the tension? Because here there should be a thread, right? So tension always acts acts away from contact, right? Away from point of contact. So which is point of contact? This is our point of contact, right? So tension acts like this. So can I put like this? Yes, correct. Very good. And what about the, this is what? Tension. This is acceleration. Very good. The body movement. And what about not always our force, right? Evergreen force. What is that? M1G. Very good. What is that? M1G. That is due to acceleration due to gravity. The force is acting M1G. So now can we write easily the equation? Come on. Let us write the equation. Body is moving downwards. So which is downward force? When the body is moving downwards means you see the downward force. So that you start with that. Okay, M1G. So the upward force, no doubt, it is negative, which is equal to what? F net. What is F net here? F net is equal to M1G, right? Sorry, M1A. M1A. So can I take M1 into A, right? So this is equation 1. Now, let us write FBD of M2. This FBD of M2 is very, very important. I will tell slowly. Please listen carefully and watch the video. If you don't understand, you stop it, you pause it, and then you continue like that. You watch so that you can easily understand this FBD of M2. See now how the figure is in the same way I am drawing. Okay. So this is just parallel to that line, right? In the same way I am drawing. This is our M2, right? M2. Okay. This is M2. Okay. Now what you do? Yeah. This is our M2. M2. Okay. Now here you observe whenever it is an inclined plane because of angle is existing, right? When the due to angle of inclination, but if it is horizontal, there will not be any problem. You are taking directly the M2 value and you are going to calculate, right? Because the block is on a inclined plane. Whenever you observe, whenever it is on the inclined plane, you see here, you see, let me draw clearly this one so that you can understand clearly. This is M2. Okay. Now here whenever you have a block on inclined plane, what happens? What happens? Actually, this total angle, because of angle of inclination, here you see right angle is formed, right? When right angle is formed, then there are trigonometric components, right? No doubt trigonometric components, right? So here, because of that, you can observe that two components, one is perpendicular component, another one is parallel component or existing. Okay. So here in this case, the perpendicular component is cos theta component and parallel component is sin theta component. Okay. Like this, we divide the total any kind of angle, any kind of quantity into two components, right? Now, what are those? Let us observe. You see here, this is M2, right? So this will be our M2G, right? This will be, let me draw clearly. Let me draw that. This will be our M2G. So here you observe this is M2G. Okay. If it is M2G, then if you draw just perpendicular to it, okay. So just surface perpendicular to it is M2G cos theta. Okay. And parallel to it. So parallel to it, this is m2g sine theta. Understood? m2g sine theta. m2g sine theta. Okay. Now, here, this is mg. So, acceleration due to gravity, because it is not horizontal, no, it is making an angle. That's why it gets divided into two components, right? Only m2g, only with respect to acceleration due to gravity, it is changing. But remaining things are same. Whatever you did in the previous case, in the same way we can do. Okay, very good. Now, what you do? Now, this is our normal. Yes, this is our normal. So the body is moving like this, right? In this direction. Okay. What is the movement of the body? Like this, no? It is moving. You see? In the same way, I have drawn this A also. Are you observing? Yes, very good. So that I will make a line so that you can understand here. Okay. This is our heading now. Now, this is the movement of our body. Now, you observe here, what about the tension? Where the tension is acting. You see, here the tension is acting away from the point of contact, right? You see, which is our point of contact? This is our point of contact. So, can the tension act in this direction? Yes, very good. So, we have taken the tension in this direction. Got it? Very good. Now, so we got the total figure. Yes? So m2g cos theta is perpendicular and f2g is sin theta, which is parallel. Now we can easily write the equation. Come on, let us write the equation. Come on, try to write the equation by your own so that you will get a clear picture. You will get a clear picture. Come on. What is our equation? So how to start to write the equation? Come on. Let us start with, sorry, this one, no, this one is existing. Okay. This is m2g cos theta. Here is this one. Okay. So now, how to write the equation? You see, this n, normal force. First, you see the body movement. What about the body movement? Body movement is in the direction of upwards. Yes, correct. So tension is positive. Yes, T. And also, you know, F net is, that is always you keep in mind. F net is equal to MA. That is here in the case M2A. Okay. Now, I am taking tension. How the tension is? Because the body is moving upwards. So the tension is also in the same direction. So T should be positive. I am starting with T, correct? And what about M2G sin theta, which is anything opposite to that tension T? Yes, very good. M2G sin theta. So minus M2G sin theta, which is equal to F net. F net is M2A. Why we are writing always F net? Because this is the total force with respect to our block. Okay. And this is the total force with respect to the system. Correct? Yes. T minus M2G. Sorry. M2G sin theta, which is equal to M2A. Correct. Now, what about any other forces are acting? Yeah, those also you have to consider. Come on. You see here, normal. How the normal is acting? The normal is acting upwards and M2G cos theta is acting downwards. So there is no movement in the up and downward direction. Up and downward direction. So we can, so what, if there is no movement means the body with respect to vertical position, with respect to vertical, it is at rest. Okay. That means the body is said to balance only in the vertical way, not in the horizontal way. Got it? Now, So when it is balanced, when it is going to balance, the two forces are equal, then the body get balanced in the vertical position. Vertical way I am taking, not position, vertical way. So can I take n is equal to m2g cos theta here? Yes, very good. N is equal to m2g cos theta. Yes, because of balancing. Correct. So this is our second equation and this is our first equation. Substitute. Now, can we calculate t of equation 1 in t of equation 2? T of equation 1 in t of equation 2. So can we calculate t values from this first equation? T is equal, so can I send t to that side? Why to take negative or something? M1g minus M1a is equal to t. Okay. So I am putting this t value in this second equation. Substitute t in equation 2. Let us substitute that. Come. So what we are getting now? Come. Substitute. So what is our t? M1g minus M1a minus M2g sin theta. M2g sin theta is equal to M2a. Okay. Now what we have to calculate? Acceleration we are calculating. Okay. So can we take all, say I am sending this M1a to that side. M1g minus M2g sin theta, which is equal to M2a plus M1, because I will need a, no? So can I take a as common? M2 plus M1, which is equal to, can we take g also common here? G into M1 minus M2 sin theta. Okay. Now what about a we are getting? A is equal to g into M1 minus M2 sin theta upon M2 plus M. Okay. This is our A value. Got it? So what is our A? Observe, come on. You observe A. G is equal to M1. Sorry, A is equal to G into this is G. Okay. G into M1 minus M2 sin theta by M2 plus M1. Got it? Okay. Yes. Now what you do is, now what we are doing is, it is M1 minus M2, M1 minus M2 G into, okay, by M1 plus M2. Okay. This is our equation. Understood? Yeah. Now what we have to calculate? We already got the value of t, right? T and a we got. So we got the main values. So what you have to remember here is, main thing is, sometimes notice, sometimes they may ask normal force, that you have to remember, and also how to draw these two, this M2G. So in how to draw M2G is, I am going to explain, so that I am erasing this one. Yeah, you try to find tension in your phone. Okay, this one. And let me tell you what are the important things. You try to find tension in phone and comment it. Okay. Yes. Let me tell you the two important things how to draw these two. Come on, look at this. Come on, observe. So that I am erasing this. So it will be clear to see only that picture, so that you can easily understand. Come on, you observe. Let me erase also. How to draw? This is our graph, right? How to draw this m2g cos theta and m2g sin theta. This also I made it. What happens? Yes, it is good now. Yes. You see, in order to draw that, first you draw a like this line. Okay, just you drop a line like this. Next, after that, you drop a perpendicular to the surface, right? That is nothing but m2g cos theta. Yes, this is parallel line which is called m2g sin theta. Okay, parallel and perpendicular, simple. This is our m2g. M2g you neglect it. Okay, just you observe our main two components because the horizontal is not whatever the surface we are taking is not horizontal. If it is horizontal, then it is parallel, no? So there is no theta existing. But here theta exists, the inclination exists. Due to that, we are going with these two components. Now you got an idea how to draw mg cos theta and sin theta components in FBD? Yes, very good. And one more thing, what is that? I told about n. So what about n? So in vertical position, how the n value will be? N value will be m2g cos theta. Sometimes they will give the angle. Okay, they already gave m2. Okay, in the question they already given in the question generally they will give, and also theta angle they will give extra theta angle, say 30 degrees. Say m2 is having some 5 kg. Okay, then what about the normal force which is acting? So how do you calculate? Normal force means you may confuse. How do you find normal force? We are calculating only T and A for this. No, N also we are calculating. N is nothing but M2G cos theta, right? M2G cos theta. So here what is our problem is having mass is 5 and G is 10 and say angle is, let us take cos 60 degrees or cos 30 you take, then it becomes easy. Cos 30, okay? Cos 30 means sin 60. Sin 60 is root 3 by 2. So to 1 time 2 5 times. So 25 root 3 is our 25 root 3 Newton is our normal force. Got it? In this way, you can easily solve any kind of problem if they ask for normal force. Okay? And next one is, so this is normal force. This is masses on inclined plane. Okay. Next one is, what is the next one? Masses with, here only one angle is existing. Whereas if two masses are making with two angles, then what happens? Right? You are observing here only mass with one angle. Now, here two masses are making with two angles. In the same, let us take this as alpha and beta I am taking. Okay, instead of alpha 1 and alpha 2. This is our M1 and M2. Okay, yeah. Now, here alpha and beta we are taking, right? Yes. Let us draw the diagram. What is our diagram? What is the name of our diagram? Is it only diagram? No, it is FBD, right? FBD of M1. So for that, free body diagram, right? You know that expansion. Yeah, M1 is greater than M2 I am considering. Let us, M1 is greater than M2. What happens? Someone observe. Can you draw? Someone try to draw the M1 FBD. FBD of M1. FBD of M1. This is also an inclined plane, right? How our inclined plane is? Our inclined plane is like this. Okay. Here there will be the mass M1. Okay. Now, what happens? What happens when mass is acting on an inclined plane? Yes. So where is tension acting here? Any tension acting or not? Yes, this is our point of contact, correct? So this is the thread, okay? A thread, and this is the block. So these two are joined at this point. That point can be called as point of contact. Got it? So what about tension? I told one important point with respect to tension and point of contact. So tension is always away from point of contact. Yes. So this is our point of contact. How the tension can be created? Yes, correct. The tension is away from point of contact. Correct. Okay, very good. So can I write tension here? Can I represent? Yes, very good. Next. What about normal force? What about normal force? Normal force is acting normal. Yes, very good. Yeah, this is N1. Okay. Why I am taking N1 and N2? Here there are two inclined planes. Okay. Two inclined planes with two different angles. So all becomes double here. So two different masses, two different angles, two inclined planes, and two normals, right? Very good. And tension, tension is single. Okay, very good. Same tension. You see, same tension, same thread we are taking. Now, same tension, same thread is continuing. So the tension is also continuous. Okay. Yes, very good. Now, normal is acting like this. Now, which is our important point? Yes, that is our acceleration due to gravity. What kind of force it is acting? That we have to observe. Now, if for this, what you have to see? Yeah, you observe this is our M1G, okay, and perpendicular to surface. Simple, you don't, no need of writing this one. Write directly perpendicular to this one. That is M1G cos theta, right? Just you draw perpendicular to that, okay? That is M1G cos theta. Just you simply drop the other one, M1G, okay? M1G cos theta. And what about M1G sin theta, where it is acting? Yeah, whenever it is acting, tension this here, no doubt, this also acting like this. Yes, M1G sin theta. Got it? Okay, M1G sin theta. So for which angle this is? For which angle? For alpha. Okay. So what is our angle? So can I take this here? This is our surface. No? I am taking the surface here. Or otherwise, let me write here. So I am extending downwards. Okay. Now this is our alpha. Okay. This is our angle. This is our horizontal. This is horizontal. It is making an inclined plane with an angle alpha, angle of inclination. Okay. Now, can we write the equation now? Yes. Why not? It's so easy. Yes. Are you agreeing with me? Very good. Come on. Let us write the equation. Now, you observe how the body is moving. That is important. The body, here M1 is greater than M2. That means M1 going down, right? This is our acceleration, correct? So I am putting here a simple small acceleration with arrow mark. Okay, this is our arrow mark A. The body is moving. So I will give special attention to that because how the body movement, that is very important. Depending upon that, we have to go for all the signs. Okay. Now the body is moving in this direction. Very good. Now, if the body is moving in this direction, now what happens? So, which is in the same direction? I told what the direction of motion of body. Which force is acting? Yes, M1G sine theta. So, can I take M1G sine theta as positive? Very good. Yes, yes. Which is the opposite force? That is T. That is minus T. Very good. Which is equal to, what is the net force acting? Net force always acts, no? Yeah. What about net force? Net force? F net is equal to what? F net is equal to M1A. Yes. This is our equation. This is our equation. This is our first equation. Yes. Next, we go to the second body, that is M2. Let us write the equation for that. Come on. Now, come on, you try your own how to draw, how to draw the second body diagram. How to draw? Come on, let us observe that. Say here how the body is. The body is like this. Okay. So this is M2, correct? If it is M2, then which is point of contact? You observe the point of contact always. So which is our point of contact? The thread and the body attached to intersection of those two, right? Intersection point. So this is our intersection point. Are you observing? So see, this is the body and this is the thread. This is our intersection point. So that intersection point is called what? Point of contact. The point of contact is away, the tension is away from point of contact, right? So how the tension acts? The tension is going to act in this direction. Very good. So can I draw that one? Yes, very good. Why not? This is our tension, correct? So if tension T is in this direction, now, so what about mg? Yes, mg get divided into two components. Why? Because it is an inclined plane. So because of inclined plane, it is going to get divided into two components. What are those? Say, this is perpendicular one. What I said? Draw perpendicular one. What is that perpendicular one? M2G cos. Because this is making an angle with beta, no? Let me draw an angle. Here, you take this as alpha, no? Okay. You take this as alpha because it is making an alpha. So here also I am going to draw a beta angle. Just extend some more. Okay. Just I extend like this. This is our beta. Okay. This is our beta. And now what you do is, this is alpha, sine alpha, okay. And here, you see, this is, it is magic. What happens? You did any magic? You know, again there will be a magic. You see, yes, I am only erasing theta, but theta is not is in contact with, like, point of contact it is coming, right? No, I make alone this one alpha. So cos alpha. Yes, very good. Now, this is our perpendicular one. This is our beta. It is making an angle. what happens? M2, this is T, tension, and then this is M, this is what? M2, M2G cos beta, got it? And this T is acting. So parallel to the inclined plane is what? Yeah, M2G, M2G sin beta, very good, correct. What you do now? What about normal? So normal always perpendicular, normal always opposite to this mg, right? Why? Normal is always acting perpendicular to the surface. Okay, this is our block surface. So this is our normal. This is n2. Okay, is it n2 in the upward direction or not? Yes, correct. Okay. Now what you do? Now, wait a minute. What you do is here you do one thing. Mg M2 M2G sin beta, M2G cos beta we got, and this is normal. Okay, normal is N2. Okay, why? Because normals are different, because we have taken two inclined planes, not single one. In before case, we took only one inclined plane, and one inclined plane only one angle. Okay, that's why we have taken only single normal force which is existing. Here we have two inclined planes, so two normal forces are existing, correct? Very good. So now we represented all forces, am I right or not? Yes, very good. But what about the movement of motion of body? That we have to represent, no? Where I represented? No. So what is the motion of the body? The motion of the body is in upward direction, right? Okay, in this direction. Yes. Let us write the equation now. This is sine alpha. Okay, alpha. So M1G sine alpha minus T is equal to M1A. From first free body diagram, M1 FBD we got. This is M2 FBD of M2. Okay. Now, what do we get? Here we are getting how the body is moving. The body is moving in the upward direction as that of T, right? So tension and both are in same direction. So I start with tension. No, normal, not general tension. Why I have to start with tension? I'm free now. Okay. I'm physically not having any tension. Okay. But with respect to the diagram, I'm following the tension. Got it? Yes, very good. Now tension T in the same direction. T now which is opposite to that, which force? M2G sin beta. M2G sin beta. Very good. Which is equal to what? M2G sin beta is equal to F net. F net is M2A. Very good. So this is our second equation. Correct. Now, what do we get? T is equal to yeah. Now we have to what we have to do? We have to solve these two equations. What are the two equations we have? 1 and 2. In those two variables are T and A. Okay. So we have to eliminate one variable, so that if you add these two, then if you add, by adding these two get eliminated, and we can easily get the value of A. Yes, come, let us do. So what do we get? If you add these two, just I'm adding, if we add M1G M1G sin alpha minus m2g minus m2g sin beta, which is equal to m1a plus m2a. Yes. So just what we did, just I am writing 1 plus 2. I am doing. Okay. This is 1, this is plus. 1 plus 2 if you do, you are getting like this. And now what we are getting? Come on, let us observe. We want, which one we calculate? A, no? Yeah. So can I take A as common? A into m1 plus m2. This is equal to G also common here. G into m1 sin alpha minus m2 sin beta. This is equal to A. So A is equal to, what do we get? A is equal to, I am writing directly. M1, G into m1 sin alpha minus m2 sin beta, m2 sin beta divided by m1 plus m2. Correct? So this is our expression. This is our expression for A when you consider the two inclined planes, which are having masses. What are the masses of two inclined planes? Two inclined planes masses are m1 and m2, which are making alpha and beta with the horizontals. Then the value of A is equal to G into m1 sin alpha minus m2 sin beta upon m1 plus m2. Now what is the other one? We need to calculate T, right? So what you do? Let us substitute the value of G in equation 1. Let us substitute the value of A value in equation 1. Let me substitute that. Come on. So just I am erasing this part. I am substituting the value of A in this. Yes. Come on, let us substitute. What do we get? mg sin alpha. This is mg sin alpha minus 3 is equal to m1 into g into m1 sin alpha minus m2 sin beta divided by m1 plus m2. Okay. Now t, I am sending t to that side. Okay. So t to that side means t I am writing this end only. Okay. T is equal to, if I send t that side, this is going to be negative, right? RHS is going to be negative and LHS is positive. So mg sin alpha minus, is it correct? Come on, check. mg sin alpha minus m1 square g, right? m1 square g m1 square g sin alpha, okay, minus m1 m2g sin beta, m1 m2g sin beta, okay. This whole divided by m1 plus m2, no, right? Whole divided by, so I am erasing this because I substituted. I don't want a value, so I am erasing. Yes. Okay. Next. This one also no need, no? Yeah. Yes. Come on. Let us m1 m2g m1 m2g sin beta by m1 plus m2. Okay. This total thing. Any cancellations or anything or any commons we have to take out. So this is m1g. m1g m1g sin alpha. m1 square, no? m m1g sin alpha. M1G sin alpha, not square. This one is M1 square, no? M1 square G sin alpha, M1 square G sin alpha minus M1 M2 sin beta by M1 plus M. Correct. Yes. Now, M1G sin alpha, M1 square G sin alpha minus M1 M2 G sin beta by M1 plus M2. Anything you have to simplify? This is M1G sin alpha. So M1 square G sin alpha, M1 M2 G sin beta by M1 plus M2. Yeah, we can't simplify this. Okay, let us take this as our T value. Okay, so what is our T? Our T is, what is our T? Come on, let us look at T. What is the T value? M1G. This is M1G sin alpha. M1G sin alpha. Don't confuse. Why I have written double means because at the beginning I wrote M1 square G. So don't confuse with that. M1G sin alpha minus M1 square G sin alpha. Okay. Minus M1 M2 sin beta. G sin beta. M1 M2 G sin beta by M1 plus M2. This is our tension when the two inclined planes are acting with the angles alpha and beta. You understood? So you try to take M1 is less than M2 in the home and you get the value of A and T. Okay? You try to solve all four types of FBDs, okay, in the home and comment it. Okay? Come on, thank you.